Hello friends, welcome to my channel Physics with Rakshit. In the present video, we will see origin and fate of universe according to book Theory of Everything authored by Stefan Hawking. This is the sixth lecture of this series of videos where I will explain Big Bang model, various eras of Big Bang model, inflationary model, what is quantum theory of gravity, in this perspective, what is the role of creator or God in cosmology? We will also see various initial condition or selection principle through which we can have present era. Let us start. In previous lectures, we saw Big Bang and various concept regarding Big Bang model that we will repeat here to begin this lecture. Hot Big Bang model in which universe was described by Friedman model or equation that we saw in previous lecture. Right back to Big Bang model. As our universe expands, temperature of matter and radiation in it will go down. We know that when Big Bang was occurred, universe temperature was of the order of 10 raised to 32 Kelvin. Thereafter, when Big Bang was occurred, temperature was go down until it reaches to present temperature. We know that definition of temperature is average kinetic energy of particles. So if we are talking about high temperature, it means we are talking about more pressure in case of Big Bang model. In Big Bang, in Big Bang model, initially volume of our universe was tends to zero, and that is why density of our universe was tends to infinite. At where temperature of universe is of the order of 10 raised to 32 Kelvin. It means universe was extremely hot at that time. Thereafter, when explosion occurred, after 1 second, temperature of universe fallen down to 10,000 million degrees, which is also very bigger amount and which is equivalent to hydrogen bomb explosion. At that time, they would have photons, electrons, neutrino, antiparticles together with protons and neutrons. At them, at that time, there were no atoms or nucleus. Only these particles were there in that system without any kind of arrangement and without any kind of system, which will form after more decrement of temperature in this system that we are considering in case of Big Bang. With more expansions, electrons and anti-electrons would have annihilated each other to produce more photon. We know that according to pair production, photon will be destroyed into electrons and positrons. If we extrapolate this procedure, we can have more photons. And this procedure leaving behind only few electrons, it means at that time there were more photons than electrons. After 100 seconds of Big Bang, temperature would have fallen down to 1000 million degrees, which is quite more by comparing present temperature. We cannot survive at the temperature. And nucleus of atom began to form. Initially, nucleus of some elements like hydrogen, deuterium, lithium, beryllium were formed, which we call stellar nucleosynthesis. At that time, nucleus began to form in the universe. Thereafter, one can observe radiation left over from hot energy early stages where temperature is equivalent to few degrees above absolute zero temperature, where expansion was occurred. We can observe this radiation by observing cosmic microwave background radiation. By observing CMBR, we can have baby picture of universe also. We can have many predictions regarding cosmology, astronomy, and astrophysics that I discussed earlier in this book also and in my other videos of my YouTube channel also. Within few hours of the Big Bang, production of helium and other heavy elements would have stopped. Thereafter, for next million years, universe would have just continued expanding without any kind of new creation. At that time, there were no atomic creation, only nuclei were there. So without anything much happening. After more decrement in temperature, once the temperature had dropped to few thousand degrees, atom began to form. And thereafter we can have observation. We know that we can observe universe by means of light. And we can have photons by transition of electron from one state to another state. And this kind of procedure happens in atom. So by this era, we can observe universe. Before that era, our universe was completely opaque for observation and electromagnetic wave. Thereafter, regions that were slightly denser than average, expansion would have been slowed down by gravity. We know that behavior or nature of gravity is attractive. Gravity attracts according to mass of given matter. So eventually expansion stopped and recollapsed began. Due to gravity, matter outside this region would have started rotation. Now we are making transition into galaxy era. What happens? Let us see. Again, due to gravity, matter outside the region would start rotation. And when region got small enough, it would be spinning fast enough to balance attraction of gravity. We are talking about birth of disk-like galaxies in which matter is rotating around center of galaxy. So this is the galaxy era. We reach to galaxy era from Planck era to stellar nucleosynthesis, nuclear era, atom era, and galaxy era. Thereafter, stellar collapse begins by dust of galaxies that I explained in many videos of my YouTube channel, also in previous lectures of these books. So what happens thereafter? What happens after gas in the galaxies would break up into smaller and clouds that would collapse under their own gravity. Earlier, we saw that there were 12 stages in stellar collapse or life cycle of star, right from nebula to dust cloud. Here, we are talking about nebula and dust cloud. We can reach up to black hole by this procedure. In life cycle of star, by condensation of dust, eventually thermonuclear nuclear fusion begins and star will start to form. Thereafter, we can have various eras of black hole by thermonuclear fusion. We know that there is a balance in star between outward radiation pressure and inward gravitational pull. So more massive star need to be more hotter to balance their stronger gravitational attraction. Our sun is the second or third generation star which was formed before 5,000 million years ago. Our sun is the average mass star which can survive for many more years. Right now it is in the middle age of its life. There are many open questions regarding cosmology and origin and fate of universe that are addressed in this book. Like, why is the universe so uniform? At larger scale, why universe start out with so nearly critical rate of expansion to just avoid recollapse? Earlier, I also explained critical rate of expansion, what is critical density, what is average density, etc. Our universe has same amount of critical rate that it could have so that we can have life in our universe, so that we can have physical laws in its actual state. Another question is why universe was so uniform? We know that at larger scale, our universe is homogeneous as well as isotropic. Why is it so? That can be addressed by many books, especially in this book. Hawking addressed this question shortly. Let us see. So at larger scale, our universe is uniform, homogeneous, as well as isotropic. Though there is a density fluctuation in universe at different region, why universe started the way it started is the biggest question. Our universe is more denser inside the galaxy and in the intergalactic space where matter is less. Visible matter is less, while dark matter, dark energy were in abundant form. We can also consider anthropic principle to address all these questions, which tells that universe exists because of our existence. If we don't exist, universe doesn't exist. Whatever forms of laws that universe has is because of our existence. So anthropic principle, we can have particular selection principle or initial condition to address all these questions. Like we are addressing or we are seeing initial condition Big Bang in this situation to address present cosmological problems. There were many problems like horizon problem, flatness problem in Big Bang model. We know that when Big Bang was occurred, different segments of our universe were very together. Thereafter, few movements, they could communicate with each other with speed greater than speed of light. If we don't consider any other model like inflationary model. And we know that according to theory of relativity, speed of light is constant. No communication could happen with speed greater than speed of light. Then how can different region of our universe have same temperature, and which is the biggest question, and which is known as horizon problem and flatness problem. So in our universe, in different region, curvature was so intense and warping was so intense. At larger scale, our universe looks flat, which is another problem. These two problems were successfully addressed by inflationary model, which was proposed by Alan Guth. So Alan Guth proposed inflationary model. According to him, early universe might have had a period of very rapid or exponential expansion. In this way, different region of universe could have communicated with each other with speed equal to speed of light, and that is why they can have same temperature and other property. They are sharing same property. So universe started with Big Bang, where our universe was hot and where three fundamental forces that are strong nuclear force, weak nuclear force, and electromagnetic force are or behaved as a single force, which we call symmetry in these three forces, or which is addressed by ground unified theory. Eventually, this symmetry broke and phase transition occurred. After broken symmetry in these three forces, various particles were created like plus or minus W, Z0 boson, and many other particles of standard model of particle physics. We know that when Einstein gave general theory of relativity in 1915, he introduced Einstein field equation with cosmological constant to prove that universe is static. But thereafter, he convinced that it was the biggest blunder of his life. But we know the importance of cosmological constant in current frontier of physics. We know that there are three values of cosmological constant, that is gamma is equal to 0 or greater than 0 or less than 0. If gamma is equal to 0, it means we are talking about static universe. If gamma is greater than 0, it means we are talking about expansion. If gamma is less than 0, it means we are talking about contraction. So inflation could also explain why there is so much matter in the universe. By inflationary model, we can address this question. There are approximately 1080 particles discovered in physics in the region of the universe that we can observe. But question is, where did they come from? We know that according to quantum field theory, frantically fluctuated energy can have quanta for shorter time. If we merge these two equations, uncertainty principle of complex conjugates, energy and time, and mass energy equivalence. It means in the vacuum, there was quantum fluctuation. Initially, it was believed that in empty space or vacuum, there were nothing. But according to quantum mechanics, if we consider uncertainty principle and mass energy equivalence, we can say that at that time, quantum fluctuation was also there. By sign convention in general theory of relativity and quantum theory of gravity, gravitational energy is considered negative and matter's energy is considered positive. So negative gravitational energy cancels the positive energy of the matter. We know that mass tells spacetime how to curve, spacetime tells mass how to move according to general theory of relativity. And by this sign convention, we can cancel out this equation. So total energy of the universe is zero by this sign convention. How can we explain the end of inflation? Is also addressed in this book. So according to grand unified theory, symmetry to be broken must have taken place very slowly. We know that initially universe was symmetric where three forces behave as a single force, and symmetry breaking according to grand unified theory occurred very slowly. And by this way, we can explain end of inflation era. In 1993, theoretical physicist Linde also gave another model which addressed another inadequacies of inflationary model, which is known as chaotic inflationary model. We know that some questions can only be answered by merging or unifying general theory of relativity with quantum field theory or quantum physics, like how to remove singularity of black hole or how to remove Big Bang singularity, which can only be answered by considering quantum theory of gravity. Though there is no complete and consistent model of quantum theory of gravity. There were many successful candidates like string theory to quantum gravity, etc., but they are still incomplete, as it demands many branches of physics and many concepts, rigorous mathematics, etc. So according to quantum gravity, beginning of time would have been a point of infinite density, as we saw here, and curvature were all known. At that time, curvature was infinite, and that is why where all known laws of science were violated, as physicists hate infinity and anomalies which are occurred in equation. So here classical general theory of relativity is failed. So one has to use quantum theory of gravity by unifying general theory of relativity with quantum physics or quantum field theory. As I told, we don't have complete and consistent quantum theory of gravity yet, even after research of many years. Thereafter, Hawking addressed that to understand singularity and all this concept of cosmology, you have to incorporate Feynman's sum over history, according to which electron will pass through all paths, and we have to average out this path by sum over history. But here there is one problem, that is imaginary time. We have to consider imaginary time, which is bit difficult to grasp for normal people who cannot understand imaginary world of mathematics. Actually, it is a mathematical trick which can lead us towards real time with more clarity. So where distinction between space and time disappears, if we consider imaginary time, here we are talking about Euclidean space time. In general theory of relativity, two possible way of universe, either it has existed for infinite time or else it had a beginning at a singularity at some finite time, like Big Bang. In quantum theory of gravity, space-time or universe doesn't have any kind of boundary. It means our universe is self-contained. We don't require any concept outside from universe. So what is the role of God if our universe is self-contained and if our universe doesn't have any kind of boundary? Is the biggest question. Here Hawking also explained cyclic universe, like from this single point of north pole of Earth, our universe start expanding. If we go to equator, at equator it has expanded to maximum. Thereafter, it will again contract and reaches to South Pole. Again, it will expand. Again, it will contract. So by this analogy, we can understand cyclic picture of our universe. So at imaginary time, there are no singularities or boundaries, and it is more basic than real time in quantum theory of gravity. Actually, in quantum theory of gravity, like low quantum gravity, there is a absence of time. We have to consider dynamics as relation, as we are talking about theories which originated from general theory of relativity. So if universe is self-contained and having no boundaries, then what place for a creator? What is the role of God or creator in this model that we are talking? So these all concepts are addressed in this chapter, that is origin and fate of universe, or sixth part of our series of videos. Thanks for listening. If you like my video, please share and subscribe my YouTube channel. If you have any question regarding this lecture, you can ask in the comment section.